Right, so for question 35, to find the half-life, we could count and just see there's 12 molecules to 6 to 3. So there's a clear half-life is every 5 seconds. We cut that concentration in half. Question 37 is a little bit harder because we don't know 8 seconds, right? They tell us at 0, 5, and 10. So 8 seconds is going to fall somewhere in between. And at 8 seconds is also not a nice uniform half-life, right? It's not 0, 5, 10, 15 based on our 5-second half-life. So we actually, for this one, we have to plug in the information into doing a calculation, essentially, using the integrated rate law for a first order reaction. So we know natural log of concentration at time t equals negative kt plus the natural log of A at time 0. We know time, that's 8 seconds. We don't know rate constant, but we can find our rate constant because we know half-life equals 0.693 over K, right? We don't know K, but from question 35, we do know our half-life. So 5 seconds is my half-life, 0.693 over K, multiply both sides by K. And then I'm going to divide by 5. So K equals 0.693 over 5. So 0.693. .1386 inverse seconds because that's seconds. So now we know rate constant, we know time, we know our initial concentration, and we're trying to find, what's our concentration at 8 seconds. So if we just call this, a 1 liter flask, this would be like 12 molar, right? Let's make our life easy and not make more work than we would need. So plug everything in. Natural log of concentration at time t, that's our unknown, negative K, 0.1386 inverse seconds. Time is 8 seconds. And then we're going to call our initial concentration 12 molar because we have 12, and we'll call it, 1 liter flask. So plus the natural log of 12. So natural log concentration at time t equals, multiply those together. So times 8. And add in the natural log of 12. So I get 1.376. So from class, right, e to the natural log of x equals x. So that means e to the natural log of concentration equals our concentration. So e to the 1.376 and I get like 3.96, so we'll call that 4. And then looking back, right, if we had 6 here, we had 3 here, we're looking at 8 seconds. So yeah, it seems reasonable that we've got like 4 molecules at about 8 seconds into the reaction. But no, that definitely question 37 is a challenging question, a lot to think about there. We had to go use half-life to find rate constant, and then use the integrated rate law actually to find the concentration at that time, because it wasn't a nice clear-cut half-life number. So does that help for question 37?
Yeah, thank you.